Alright, the first electron configuration we're going to do is thallium. Now, thallium has the symbol TH, and if we look for it on the periodic table, we find it at 90. So it's right here. So thallium at TH has 90 electrons. Okay? So again, starting with the periodic table, we're going to add electrons all the way from hydrogen through to thorium. Okay, so I'll leave this down here temporarily. First two are going to be hydrogen and helium. That'll be 1s2. Then we'll go to lithium through beryllium, which is 2s2. Then boron through neon, which is 2p6. Then we go sodium and magnesium, which is 3s2. Aluminum through argon, which is 3p6. Fourth energy level starts with potassium, so we'll do 4s2, potassium and calcium. Then we're going to do the 3 Ds, because the Ds, remember, start one below. Then we'll go back to gallium through krypton, which is 4p6. So then we're down here to rubidium, which is 5s2. Then through the Ds, 4d10. Back to the Ps, 5p6. Okay, so now we're at xenon. So now we're to here, which is 1, 2, 3, 4, 5, 6. So 6s2 is cesium and barium. Then we're going to go to the lanthanides, which goes all the way through here, which is 4f14. Come back through to the 5d10s. Okay, then we're back to the 6p6s. Okay, brings us down here to 87 and 88, which is 7s2. Okay, brings us to the actinide, which is 6d1, and then down into the 5f1. So we went all the way from hydrogen through to thorium, which is down here on our periodic table. Now, if we look at it, we wanted the extended, but we can do the shorthand. If we look at 90, 90 is right here, so the nearest we have is the radon core. And then we have the 7s2, 6d1, 5f1. And we can always double check it. Radon has 86 electrons, so that's 88, 89, 90. That matches our electrons there. Okay, so that's how we do both the extended and the shorthand. Now, I'm going to put the periodic table away for the moment and work on some of the other ones. If we're going to do thorium 3+, we're going to lose 3 electrons. Well, the 3 we happen to lose, these are the intertransition metals, so we're going to leave the 5Fs alone, are going to be the 3Ds and the 6D1s. So what we would do is, for the extended, we would write everything, but those, we'll do this in the shorthand because it's just easier to write. So we'll lose this 7 S's and the 6D, and you can write it like this, or you can just remove them totally, so we're left with 5F1. Okay, now an excited state, we move an electron up to a higher orbital, but we do not lose it. Okay, so again, if we're starting with this as the core, we can move anything we want up. Typically, for simplicity's sake, I'm going to remove an S. So I'm going to move one S up. Now I can move it into any one of these that are already filling, or I can move it up to the next energy level. You can move more than one, but typically, for simplicity's sake, we're going to only move one. And notice we didn't lose any electrons. We still have 4 plus the radon core, but we moved it from the 7s up to the 8s. So this completes the thallium problem. We'll work another one in a minute.